I'm hoping I'm going to be able to flip the image because I got it upside down. I want to show you something. Stan Myers made a ring, copper pipe, made a ring. So that's a pipe, like that, a pipe. And it went round in a circle, this pipe. And he had a laser, and he like a 200 milliwatt laser, like one that cost about £5, £10 on eBay. Really cheap pen laser like this. Nothing special. He put that on this pipe. This pipe had a vacuum pump, so you just have a vacuum. Two gases. Two gases. Right? One was argon. I forget why. Forget the other one. But I could look up. I don't even need anyone to know the other gas. Because it was a magnetic and a paramagnetic. What would that do? And then you create a vacuum with them gases in there. Argon, which is one, with a magnet and a paramagnetic. You're creating gases in a... Say this is the 2D dimension of that, side on. You're creating two gases. You're creating one gas that'll go outside. One gas, magnetic, paramagnetic, they're the opposite. One gas would go to the inside. You're basically creating a radial magnet in a tube, which is what? CERN. Yeah, but you're doing it with two gases to hold in the middle, which is like my magnet. So this is where, once you understand the magnet, you can understand so much more, which is why no one's allowed to know what it is, because no one really understands this, even from Stan Myers. No one understand, well, there'll be some people, how it worked. They're just showing you a ring and some coils around it. Like that. And you tap the energy off the coils, and it's and you use this circuit, and it's all irrelevant. You got coils around it because you got your magnetic and paramagnetic gases. You shine a light, right? If you use the magnet I made, right, so it goes to the center point, and you put them around this in the opposite two opposite polarities, you created this center point for your laser. When you hit your laser in there, it's gonna go round and round. Accelerator, yeah. It'll go round and round and round. It's in a vacuum. So it'll go round and round and round, right? Without any energy. Because if you now add, say speed of light, an example is 10 miles an hour. And through the air, it travels at 10 miles an hour through the air. So say through the ether, it travels at 10 miles an hour. Once that hit water, it goes down to about 8 miles an hour. What happened when it come out the other side? If you're going on a tank, you shine a light through it, it goes down to 8 miles an hour. What happened when it get air? Does it carry on at 8 miles an hour? No, bruv, because it's constant. It goes back up to 10 miles an hour. So you're taking the EM field out of the light, which is spinning round and around, so you only need to put pulses into it, yeah? It's spinning round and around and around, creating an EM field through the gases, charging the coils, CERN, yeah? And then you're getting the free energy from a tiny little pulse of laser coming in. That's that, yeah? That's Stan Myers, okay? But then I got my magnet, yeah? Which is an Evo. It is an Evo. It's a current loop. That's how I look at it, as a current loop. It's a radial magnetized, which is the two gases separated by magna, paramagna. That means one will go to the outside, one will go to the inside. You're creating like a nucleus. So you're creating that magnet. So then, what does what does Nigel Cheese do? Nigel Cheese explained he used this light, doesn't he? He used this board and it's got all the lights on it. And he say, with this board, with my lights, each light, this board, this big at work, night and day, radiant energy. You know an LED is over unity because an LED is 0 point. So when you get to an LED, this is 0 point. It's over unity. The light you get out of that to what energy you put in. Look how bright they are from a 0 point energy. So you're getting light energy, 0 point energy coming in, a positive and a negative on an LED, right? And then you're putting it through the Evo. Yeah? You're putting it through the Evo and coming out, and you're getting what? How many kilowatts? For his little panel, you're getting kilowatts of energy, right? Which is like Stan Myers. And in the NASA document, what does it say for space-time? In the NASA 1979, they pulse laser through that magnet. Because it creates this, like, I'm no good at drawing. Just like I'm no good at writing. It creates this thing, doesn't it? I can't draw what... I'm no good at drawing. It's in my head, I know. But so it creates this bit there. So then it's a radial magnet. And then these energy fields come out here. But when you put light, the laser through this, that's their propulsion system. When they pulse laser through it. So what happens if you now have your Evo and then you got your light board, and you pulse, you don't have to have it, the light, you can put it through the coil, electric is light, yeah? You put it through the coil, you're pulsing light through the Evo, because even Bob Greener, how do you keep an Evo alive? You have a fish tank bulb, which is a UV bulb for reptiles and things like that, which is a photon bulb, which feeds it photon light to keep the Evo alive, yeah? So, when they're talking about if you want to keep the Evos alive for his, the thunderstorm generator, which I don't get what they're doing, I do, they're cleaning up the thing. They've got Evos in the water to transmutate the carbon to clean air out. But that's irrelevant because they're not overproducing energy. So to keep the Evo alive, the magnet, the propulsion system alive, you need to feed it light. An LED gives light, radiant energy to the 0 point, comes down the wire through the Evo out. And how many do you get from this array of bulbs? Kilowatts. So that's how it works. No one's breaking it down of how this work to this work to how this work to then how this power system work. And then I could break down more power systems, but then I'd lose people. So radiant energy, you need a panel about this big. What do you get out of a panel this big? More than you would a massive one, because you're putting it through the Evo. And this is what the Evo is. So I've made an Evo. Yeah, an Evo with a magnet rather than a charge cluster. So you can class my magnet as a charge cluster. It's no different. So that's how it works. So how easy is free energy? It's not free energy. You're pulling it from neutrinos and the light photons to there. You create a positive and a negative. You get a voltage on a light bulb. You know you get that. A voltage on a light bulb. When you put an LED outside in the light, you get voltage. You get voltage at night time because there's radiant energy. Cosmic. So you know you get that, and then you put that through the Evo, which what does that do? It pushes it through a... If you look at another thing I show you on the magnet, when I put the foil thing over it, the what do you call it? Ferrofluid, ferrocell over it. You see a low pressure gradient. What's that then? If you now got that outside atmosphere as well as that, and then I got a pressure there where I can now put an iron bar through it. If I now put an iron bar through this and an iron bar through that, what's the difference? The pressure difference is really big on there to there. So if this is a positive pressure, yeah, when I now put it through a negative pressure, what have I got? Positive, negative. So what happened when you put it through an Evo? A positive light through a negative gradient. What's that? Potential. So what's that? It's a what? A ground state anywhere. It's a floating ground state. It's a virtual, like you get virtual particles. It's a virtual ground, which goes to space-time. So now I've got a virtual ground to the outside radiant energy. Do you get it? So there's no such thing as free energy. Nah, bruv. You're pulling the light, you're pulling that through there, and you're putting it through a different pressure situation, which is this. The radiant energy is what? A massive reservoir. So it's a dam, a reservoir full of water. That's the air. And all we're doing is tapping off all that energy, all this positive. We're putting it through a negative, yeah, to ground. And we can pull it in, look, as much as we want, unlimited. We'll pull it in because we've got the magnet that will create a negative pressure. What happens when you get thunderstorms and everything like that? You have a high pressure and a negative pressure. And what that do? Create what? So you're not creating nothing new. You're creating what's already there. So yeah, well, you can't use you can't get energy from here because everything around it is here. You can't get energy because this is zero. When you read it with your meter, it's zero, isn't it? Because if I now put a meter anywhere, it's got to read zero. But what if I put that meter 100 meters up? You get like 1,000 volts. So the energy is already there. So you're only doing what the power lines do anyway, because they're working at like 12 kilovolt in the air. They don't get cable losses across country. The ether is all around the charge. All they're doing is sending like a guitar going bing, bing at 40 hertz, which pluck a frequency down this wire, which plucks the ether. So, and then they're getting the energy from the claps. So all you're doing is creating a waveform down a cable. The energy's already there, hence no losses. You can run a cable at 12 kilowatt as far as you want. If you now cut this wire here and cut this here on a one that go across the country, you still got to short it out to touch it because it's still got the 12 kilovolts on it. Because the voltage, the energy isn't even coming from the power station. There's no energy coming from a power station. There's all the energy coming from the power station. No, it's a frequency generator. That's it. It's just generating frequency, pulses. It's like an audio amplifier. And then that's the pulses. The energy's already there. And then they're plucking it out. So that's how that works. So you can't get energy from that and while you're using it, bruv. And then it goes down to what? Usable energy for a capacitor. Or a big transformer. But a big capacitor turns this energy. A capacitor, another reservoir. So you'll have a big reservoir, a big capacitor, and then you'll have another same voltage one, a small one, and then you'll have a little bank of them. Because say that's 240, this little one's 240, so you got a massive reservoir from this to a small reservoir. And then you got to step down 240 to 14, so you divide it into how many you want to bring it down in small ones. And then you tap a positive and negative off that one. Do you see how it works?